Hello, good morning, student. I hope you all are happy, healthy, and everything fine. So, what did we discuss yesterday? Yes, we discussed about the protecting and the deprotecting of hydroxyl of 1,2-diol, 1,3-diol and 6-diol. With the suitable example, we have seen at what condition we are introducing that protecting group, in which condition we are removing it, and at the reaction condition necessary carry out transformation at the other end in the compound. That type of the thing we have discussed yesterday. Today we are going to, today we are going to talk about something. It is also related to as a protecting and deprotecting. One terminology or one term normally used here is a chemoselectivity, right? Chemoselectivity. So what does it mean, chemoselectivity? Chemoselectivity means in a compound more number of functional groups are present, the reaction is carrying out at particular, we want to convert one particular functional group into as a suitable or desired product, and there is a necessary to protect that group, and that's why we are introducing the protecting group, so that the protecting group is a group which can be the temporary modification of the group is known as a protecting group. By doing that, we are keeping in a mind that protecting group should be introduced under mild condition, and it should be removed under mild condition, and it should be stable at a reaction condition necessary carry out the reaction transformation at the other end in the compounds. So that type of the thing is called as a chemoselectivity. Means selectively we can get the desired product by protecting the another functional group. For example, let us look at the suitable example which can explain the meaning of that chemoselectivity. Now let me draw one structure here. Let us see, this is one of the structure of this one NH2 and this one HO. Everybody knows that hydroxy group and amino groups, they are present at para to each other. So that type of the compound we can call it as a para aminophenol or 4-aminophenol we can call it, or in other way 4, or we can call it as a P means para aminophenol, or other way around you can call it as a 4-hydroxyaniline, or we can call it as a para-hydroxyaniline. If you look at here, there are two functional groups are present. One is a hydroxyl group and one is a amine group. This one is called as a hydroxyl group or phenolic group. this one is called as a amino group. And if this is this compound, if you treat with the reagent, like take as a concentration of that reagent is high concentration of acetic anhydride, and it is heated at 100 degrees centigrade. Take as a toluene as a solvent here. At a reflux condition, what do you get? Both are reacting functional group. Here both get esterification reaction takes place, and we are going to get here the product like this. Here NH, then C double bond O, CH3 you can call it, or here O, then C double bond O, and this one CH3 acetyl group. This one is called as acetyl group. Both the group get reacted, and we are not getting as a what we can call it as we know that suppose this suppose we want the compound like this. This is the compound which we want here, NH, then C double bond acetyl group, and this one. And everybody, most of you might be knowing what is this. This is one of the drug. This is called as a paracetamol, right? This is a paracetamol, and paracetamol when increase as a fever, that is used as an analgesic, right? This is used as an analgesic which can reduce the this type of the activity they are showing, and that, and as well as it can decrease the fever also. So that is a well known medicine we can is there. So how do you prepare that one selectively, and that is called as a chemoselective. Now here what is happening here, NH2 group as well as hydroxy group, O minus groups are there, right? OH2 minus or NH2, right? NH2 minus and OH minus are there. Among these two, which one is a more nucleophilic? So which one has a more nucleophilic in nature? Now here NH2 minus is a more nucleophilic than the OH minus, because it can readily why it's so, oxygen atom is, as we know that oxygen atom is more electronegative than the nitrogen atom, and therefore the capacity of holding the electron tightly by that oxygen atom is greater than the nitrogen atom, and therefore this one showing as a more nucleophilicity than a hydroxyl group, and that type of the thing is that type of the groups are there, and therefore selectively we want to prepare this. So this compound, same compound, let us see here, this compound 4-amino phenol we can take here, then NH2, then if you take as a one equivalent of acetic anhydride, as we know that the structure of acetic anhydride will be written like this, C double bond O, C double bond O, CH3, and this will be what we can call it as a treated with this one acetic anhydride. So selectively it is a controlled reaction. We are going to get only the product is this one, paracetamol, right? Very easily we can do, but the reaction is a controlled reaction. Controlled reaction are carried out, or that reaction can be done with the help of one equivalent of acetic anhydride, and we will get this type of the compound. Or other way around, we can deprotect this selectively, or suppose this is a starting compound, that is a 4-amino phenol or para-amino phenol. If it is treated with same reagent, that is a concentrated concentrated acetic anhydride Ac2O, then toluene, reflux condition, or what we can call it as 100 degrees centigrade. What do you get? You are going to get both the group get reacted. We will get NH, then double bond O, this acetyl group O, and then C double bond O, CS3. Now selectively we can deprotect one of these group, that deprotection selectively, and we can achieve our target molecule like NH, C double bond O, this one, and OH. But what will be that in a acidic position? Because this is the amide group. Amide group is required as very vigorous reaction for deprotection, but this in a acidic medium it can be easily cleaved, and we will get the desired product, that is a para-acetamol, and which can be used as a medicine. So that is the analgesic. We know that this is the property associated with this molecule. So this is all about the chemoselective, or what is a protecting group. And as I have told you many times, what is the ideal protecting group? Ideal protecting group means ideal protecting group should be introduced under mild condition, and second criteria, it should be removed under mild condition, and third criteria and the important one, it should be stable at a reaction condition and necessary carry out the transformation at the other center in the compound. So that are the some of the criteria for the ideal protecting group. So I think with this we have completed the protection and the deprotection of the hydroxyl group. Now we are moving toward the next important functional group, which is a amino group, right? Now let us look at second one, that is B, we can call it here. So first A, we have seen hydroxyl group here, R, hydroxyl group, or alcoholic hydroxyl group OH, and second one we are going to learn here, amines. Amines means we know that the general formula or amine group is a NH2 group. And now we are going to talk about the protection of the amino group. And as we know that the amino groups for the protein synthesis or in a peptide synthesis, because most of the amino acids, there are 20 amino acids are there, that we will see later on, but their amino groups are present. How it is what are the protecting group used to protect the amino group, and how, what are the in what condition they are removed, and whether they are stable at reaction condition, in what reaction condition they are stable, that everything we are going to learn step by step. So first, there are so many, there are number of protecting group which can protect the amino group, but selectively those are actually using in the laboratory, in the research laboratory, for the transformation of many reaction to achieve the target or to achieve the desired product. That few of them we are going to learn. I think for protecting that amino group, as far as your syllabus is concerned, I think there are 5 protecting groups are there. One is a benzyl, second one is a acetyl, third one may be as a, I think CBZ, fourth one is a BOC, and fifth one is a FMOC. These are the 5 main protecting group we are going to learn here, or we are going to discuss here one by one, and how it is introducing, at what condition they are introducing, at what condition they are removing, and how they are stable at what condition, that we are going to discuss here. Now first important protecting group, because we are talking about the protection and the deprotection, and therefore now we are arriving of the second functional group, that is a amino group, amines. And as we know that amines are the organic bases, and that organic bases in general, those organic compound containing nitrogen atom, are basic in nature. Why they are basic in nature? Because according to as a Lewis theory, they are capable of donating as a lone pair, because nitrogen containing as a lone pair, non-bonding electron pair present over there, and therefore it can readily donate, and that's why amines are basic in nature. Now this amines, first protecting group we are going to learn, that is a benzyl chloride, right? First one is a benzyl. And this benzyl, generally we know that benzyl is nothing but as a benzyl chloride. Here we can call it as a benzyl chloride. Benzyl is a group, benzyl chloride generally we are using, and that benzyl chloride, in short we can write PH, then CH2Cl, or in short we can write BnCl, or we can write the structure phenyl, as we know that the structure of this one, benzene ring CH2 and then attached as a Cl, and this part is known as a benzyl part, right? This is a part of benzyl, and that's why it is, or this benzyl is nothing but as a after the, when chlorine atom leaving its taking its bonding pair along with, and you will get as a, this type of the parts are there, this one PH, then CH2 positive, and that's why we can call it as a benzyl here, right? Now it is a very suitable reagent, the introduction of that benzyl group in a basic medium. We are introduction of that benzyl group, introduction of benzyl group in a basic condition, and what are the base we can employ here. So here let us see as a starting compound, suppose we have a benzene is a amines is RNH2 or RRNH, then that will be treated with benzyl chloride. We know that benzyl formula is a PH, then CH2Cl, right? Now after that you are going to get here RNH, then this one CH2 and the PH. This is the protecting of amine group. Now the deprotection can be done by using, that is called as a hydrogenolysis. Hydrogenolysis, the reagent, you know that the hydrogenolysis means by using as a S2 in presence of palladium and charcoal. This, and as I told you at the beginning, this hydrogenolysis or the palladium in presence of charcoal, what it do, it is breaking the bond between this, and we are generally getting that RNH2 amine group back, and the side product is obtained as a toluene here, toluene, right? This is a toluene we are getting after the hydrogenolysis. So this is the simplest protection and the deprotection. When protections are carried out, at a particular reaction condition, and they are stable at here normally used as a K2CO3 as a base, potassium carbonate used as a base, and therefore we are getting as a this type of the protecting groups, and after the hydrogenolysis we are getting as a amine back, and the toluene is a side product obtained in this reaction. This is all about this one. Now let us look at the mechanism of this. The mechanism the mechanism of protection. Here let us look at as a mechanism of protection. Mechanism of protection, just now we have seen the starting compound is RNH2 amine that will be treated with that K2CO3 potassium carbonate, which is a base. What it will do, it will abstract the proton, and we are going to get here RNH minor charge and plus, that will be treated with this group you can write here, then benzyl chloride Cl, and as we know that this benzylic carbon is electropositive in nature. Why it is electropositive in nature? Because that chlorine atom is a more electronegative in nature. It pulls the electron density from the carbon atom, and that's why it electropositive in nature. That is going to attack on this carbon atom. There is a departure of chlorine group, and the resulting compound is formed as RNH, then CH2 and this phenyl group. This is the protecting group of the amine protection, right? So that is the thing we are getting. Now let us look at as a mechanism of deprotection. Mechanism of deprotection, and now mechanism of deprotection can be done with the help of hydrogenolysis. And as we know that let's take down this example again, R, then R, NH, then here CH2 and then phenyl. And as we know that hydrogenolysis, the reagent used there, hydrogen in presence of palladium and charcoal is used as a support there to break the bond between hydrogen and hydrogen, and we are getting as a free radical type of the hydrogen atom over there, and that process is known as hydrogenolysis. And hydrogenolysis only breaking the benzylic heteroatom, like this is a benzylic heteroatom, nitrogen or oxygen or sulfur. It is selectively breaking only that benzylic bond get cleaved easily. Now look at here the hydrogen atom, here another hydrogen atom. So like this is go on forming as a bond here. Here becomes as a CH3, here becomes as a RNH2. That mechanism, as we know that it is a imaginary, so that you can get here CH3, and this is a toluene formation, right? This is a toluene is a side product obtained during the hydrogenolysis. This is one of the benefit of that reaction. So this is all about the first one, amine group. Now let us look at the second one is a acetyl group. Second protecting group is a acetyl group, right? Second one, let us see the acetyl group. Second one will be the acetyl group. You know that the acetyl group, right? Second one is the acetyl group. Sorry, here Acetyl means what? We can call it as acetyl means AC, or generally this is a CS3, C double bond O, positive charge are there, that group is called as acyl group, and the acetyl group can be obtained from this type of the reagent, that is C double bond O Cl acetyl chloride, or it can be obtained from acetic anhydride. We are generally writing as a Ac2O means acetic anhydride, or sometime we writing ACOH means it is a acetic acid. And acetic acid is heated at 200 degrees centigrade. You are going to get the compound chemical that is nothing but as a acetic anhydride, and this in short we can write for your sake of convenience C double bond O, C double bond O and the CS3. So that is the structure. Acetic anhydrides are readily available. Most of the reaction can be carried out by using as a this type. Now this is a second one. As we know that the first one is amines, NH2, R secondary amine you can consider here, R dash H, that will be treated with acetic anhydride in presence of, maybe used as a base sodium hydroxide or whichever it may be. And now what do you get here? R, then C double bond O, CS3. Acetylation takes place, means this amine group get protected. Now this we are introducing this compound in a presence of maybe as a neutral condition, and after that what you are going to do here? NH, R dash, R C double bond O CS3, and next one it can be treated removed under the basic condition OH minus. You will get R NH, then R, and plus side product maybe as a ACOH, acetic anhydride. So this is a simplest what we can call it as a simplest reaction, protection and the deprotection. Now let us see the mechanism, how the mechanism takes place, mechanism of protection of this acetyl group. Let us see here R, N, H, then R dash that will be treated with this one CS3, C double bond O, C double bond O, CS3. This lone pair easily attack on that carbonyl group, removed it, and you will get R, N, then R, then C double bond O, CS3. So that is a protection of this group, and this group can be removed by using as a this becomes as a amide. Amides are what we can call it as a very stable one, and so let us look at as a mechanism for the deprotection. Very vigorous reaction takes place here. The deprotection can be done in presence of the basic medium. We are going to get here R, then N, R, C double bond O, then CS3, that will be treated with suppose as a OH. Here this is a mechanism of deprotection. OH minus is attacking over here, then revolving this double bond around that negative charge over there, R, N minus, R, and then this will pick up the what we can call it from water like this, and you will be getting as R, N, R and the H, that is a amines back here. So in this way we have learned two protecting group for amines as well as chemoselectivity. I think with this, let us stop today here. Remaining we will see the next time. Thank you. Have a nice day.